We've looked at use cases with a centralized database like MySQL. We've also looked at a couple of use cases with a public blockchain that supported smart contracts using Ethereum. Now let's turn our attention to another interesting development, a database that supports blockchain-like features. Specifically, let's take a look at BigchaindB. We mentioned earlier that BigchaindB is a database with blockchain characteristics. So what makes BigchaindB look like a blockchain? If we think of a typical database like MySQL, this database allows mostly anyone to create new records, read them, delete them, or update them once they have access to the system. BigchainDB, on the other hand, does not support deleting records, nor does there exist a concept of updating an existing record. Users can append to an existing record, but the original record stays as it was. Users can mark an asset as burned, so it can't be used again, but this asset doesn't get deleted. This concept of burning an asset is similar to the idea of retiring money out of circulation to make the remaining supply that much more valuable. This fits in well with the blockchain philosophy. Transactions are also lumped into blocks just like in a blockchain, but there is no mining operation in BigchainDB. And similar to blockchain, there is a consensus mechanism between participating nodes, but the consensus mechanism uses a voting system instead of concept of mining. So let's look at another use case now with BigchainDB. Let's look at a use case that's pretty popular with a lot of blockchain startups and large enterprises. These companies are prototyping managed health records on a blockchain system and managing patient identity on this blockchain system. Countries like Estonia and Australia are already using blockchains to manage health data and broker transactions among patients, healthcare providers, and federal insurance programs. Startups like Medical Chain use blockchain technology to securely store health records and maintain a single version of the truth. Different organizations such as doctors, hospitals, laboratories, and health insurers can request permission to access a patient's record to serve the purpose, and these accesses get recorded as transactions on the distributed ledger. Now, an asset is not released to a requesting party like a doctor or a hospital unless the user authorizes access to this record by explicitly signing or approving this transaction using their private key. Note that this private key is only in the possession of the user, so only they can unlock their own records and make sure that these specific transactions or records are visible to authorized entities. And once these records have been used up or value of these records has been exhausted at a particular entity, the user can simply revoke access to these records. In this use case, we'll be looking at a simplified DApps hospital where patients can generate unique identities and control access and revoke access to their records via their unique identity. Doctors and hospitals can access patient records only when authorized by the patient. This has been adapted from an open source project, Farm to Fork. We created our own instance of BigchainDB in this case. And of course, following the pattern we established earlier, we'll employ a front-end user interface and then a back end blockchain database interface. In this case, our backend happens to be BigchaindB. So a few key things to note is in BigchainDB, like we said before, there's no way to delete records in the system. So this emulates the blockchain immutability characteristic. At the same time, there is no concept of mining in BigchainDB. So in that respect, it doesn't have that key security feature of public blockchains. Similar to blockchains, only patients holding their private key can transact or authorize access to the records, but anyone with authorization can verify that transactions actually occurred on the chain. So there is a natural built-in audit trail left behind as users, hospitals, doctors, laboratories are accessing patient data. One more thing to note is that in the case of BigchainDB, there is no support for smart contracts, nor is there a concept of tokens like we saw in the case of the public blockchains. There is still the concept of consensus by voting. So in this case, there could be consensus between different participating nodes in the network. For example, the hospital could have a node, the lab could have a node, and so on and so forth. So that's why we mentioned before that BigchainDB is a database that has some of the characteristics of blockchains, but it doesn't support all the features of